Principles and concepts of circular economy. The textile industry is globally recognized as the second most polluting sector, trailing only oil. It currently accounts for about 10% of all global carbon emissions. However, circular strategies offer powerful mitigation. By shifting to regenerated fibers instead of virgin ones, we can slash that carbon footprint to less than 5%. Circular textiles require a massive systemic shift. We have to eliminate waste right at the drawing board. This means utilising eco-design strategies like design for recycling and design for disassembly. By avoiding complex material blends and standardising components, we ensure that garments can be easily taken apart and reintegrated into the production cycle without requiring massive amounts of energy. Our next principle is resource regeneration. The ultimate goal here is fibre-to-fibre recycling, taking old textiles and spinning them into new, high-quality yarn. Take regenerated wool, for example. By processing used garments or scraps, we drastically cut down on the water and energy needed for virgin fibres, keep waste out of landfills, and prove that sustainable fashion doesn't have to sacrifice aesthetic quality. To make this work, we must adopt product life cycle thinking. This means viewing a product life as a continuous loop. We design it to last, we produce it using regenerated fibres, and we ensure the user can repair it. Finally, at its end of life, the materials aren't thrown away. They are collected and looped right back into the production cycle. A vital part of the cycle is designing for longevity. We have to fight the rapid obsolescence of fast fashion by using durable materials, designing garments that are easy to repair, and focusing on timeless styles rather than fleeting trends. Keeping a product in use longer is the simplest way to save natural resources and reduce our overall environmental footprint. In regards to the technological innovations and technical textiles, advancements in material science and processing are essential for achieving a circular technical textile industry. For example, in waterless dyeing technology processes, innovations such as pressurized CO2 dyeing, for example Daiku, eliminate the need for water and hazardous chemicals, allowing for a 100% pure dyeing process where 95% of the CO2 is reused. Considering sustainable fibre development, the industry is shifting toward biological nutrients like Tencel, a biodegradable wood pulp fibre, and certified organic cotton, which can safely return to the biosphere. Digitalisation also plays a huge role before a garment is even made. By replacing physical material samples with high-resolution digital models, we eliminate the logistics and emissions of shipping prototypes worldwide. It dramatically cuts material waste and allows global design teams to collaborate and iterate in real time. The numbers back this up. Resource efficiency in circular practices is staggering. Fibre recycling can save up to 29,000 cubic metres of water that would otherwise be used to grow raw materials. It also diverts over 1,000 tonnes of greenhouse gas emissions by skipping the energy-intensive extraction processes. We are literally turning waste into a high-value resource. To scale these innovations, our business models must evolve from ownership to service. In the performance economy, consumers might rent a garment rather than buy it. Because the company retains ownership of the raw material, they are financially incentivized to make it durable. Managing this requires strict traceability, often utilizing blockchain to create a transparent, unalterable history of the product's life cycle. But how do we get those rented or used garments back? Reverse logistics is a key process that involves setting up organized systems to collect used or worn-out textiles after their initial use. The collected textiles are then sorted, cleaned, and transformed into high-quality secondary raw materials. This reduces the need for virgin resources and minimizes waste. Reverse logistics is important because it closes the loop in the product lifecycle, ensuring materials stay in circulation. It also helps reduce landfill use and environmental impact. Finally, we have to acknowledge the socio-technical hurdles. Transitioning an entire global industry is complex. While climate awareness and innovative startups are pushing us forward, established multinational companies often resist this change to protect their current profit models. Combine this with a lack of funding and the technical difficulty of recycling complex fibre blends, it's clear that while we have the vision, the practical execution requires ongoing systemic collaboration.